I'm just going to put a quick poll up on the board. I just want to get an idea of who spent some time on the questions that you were given before the lesson today. Remember, it's anonymous, and like even if it wasn't anonymous, I'm not going to get cross with you. I just need to get an idea of who has spent time on the questions and who hasn't spent time with the questions, because that changes how I can go over them with you guys all as a class. Okay, so I'm just going to put a quick poll up on the board. All it is basically is to tell me sort of how much time you've spent on this lesson so far. So first one is like the first option, you haven't spent any time looking at the questions. Second option, maybe about 15 minutes. Third option, between 15 minutes and half an hour. And then the last one, more than half an hour. So just give me an idea of where you are at. So how much sort of time you spent on this. And then I can know where we're at. Just keep them coming. Just so we can get an idea of where everyone is.
I'm glad there's people who spend more than half an hour.
Yeah, that's great. That's really great. So guys, because we only have an hour and a half for this and it's quite a lot of work, we are going to have to go through it quite a lot quicker than we go through the work on Tuesdays and Thursdays, which is why it's better to have sort of done some of this before the lesson. But I know that's not always possible. Sometimes life gets in the way. Sometimes you have tests and work and it just gets a bit busy. So I do understand that as well. So if you've just joined, please, can you just quickly answer this poll so that we can get everyone in, so I can get an idea of what you've done, and then we can get started on this question. We're going to start with all the function questions because that's what we've been spending time on in class on Tuesdays and Thursdays, and then we're going to jump back to trig and see how everything goes. Oh, that's crazy. It's like equal for everyone at the moment. Okay. Okay, so just keep your answers coming in. So once you've joined, just as soon as you've joined, just do the poll for me quickly, and then we'll get going on this lesson sort of as quickly as possible. Okay, cool. Thanks. That should be enough of an idea for me. Okay. So let's get going. So this is sort of directed at the people who have had a look at the questions and have had seen, you know, have given some of them a try. How did the questions feel? Were there sections that you felt better in? Were there sections that you felt worse in? Was there a specific question that you really struggled with? Sort of talk me through a little bit about your experience when you were looking through these questions. So anyone who gave any of the questions a try, tell me how it was. Tell me how you found them, what you struggled with, what you were happy with, anything. Any kind of feedback from anyone who spent any time on the questions. Just let me know. You can put your answers in the chat for me, or you're welcome to talk me through it. Just remember to use the hands up emoji so I can unmute you. Okay, Tiama, it was okay. That's not a bad answer. Okay, it's good. Okay, so for functions, you did the first one. So you did the first question. All right, cool. And Dees was saying thumbs up. So I'm taking that as a good thing, as a good question marker. Oh, you did all the trig work. That's excellent. Cool, cool. And remember, this will be such good, the things that we're going to talk about today, it's going to be really good revision for your exam, which will be great. Get everyone on the right track. Nondesimo says thumbs up as well. That's great. Good. I'm glad. I hope that our lessons have helped with some of them. Let's jump in and see how we can go. Okay, so these sections will be in different exams. If you are going to, better than expected, that's awesome. If you are writing, a lot of grade 10 papers in June only give you one, like a lot of schools only give you one exam. But if your school is a school that's going to give you 2 exams, so you have a paper 1 and a paper 2 exam, your functions are going to be part of paper 1 and your trig is going to be part of paper 2. Okay, so they'll be in 2 different papers, and functions will make up quite a substantial part of your paper 1, and trig will make up a substantial part of your paper 2, because most schools haven't done geometry yet. So it'll be a lot of your paper 2 will be trig that you've learned this year. So these are both sort of big sections when it comes to your exams. When you are thinking about your functions, if you are someone who tends to get stressed in an exam setting. So if you think about yourself and you think as you start writing, you normally are nice and calm in the beginning and then you start to spiral and you get stressed. If you're one of those people, because that happens to a lot of people in maths, then what I recommend is writing a few things right at the beginning of the paper just to help you sort of think about things to keep your head straight. So for example, if we think of functions, can you quickly give me the different equations for the different functions? So let's start with the first one. So let's start with a straight line. What is my equation for a straight line? Y is going to be equal to what? There we go. Nice, Portia. Beautiful. Okay. What is my equation for a parabola? There we go. Nice. AX squared plus Q. Beautiful. Okay. What is my equation for a hyperbola? Y is equal to what? So this is the one we've just done in class this week. Nice. Well done, Kelly. A over X plus Q. And then we also have an exponential, which we haven't actually done in class yet, but some of you may have done them in your own classes, which will be Y equals A to the power of X plus Q. Okay. You may have learned it as A times B to the power of X. It depends on how you've learned it. So don't panic. Okay. All right, so those are our different equations of our functions. And if we write it out in the beginning, one of the biggest mistakes that happens in functions questions and exams is that students take the wrong equation and they start working things out with the wrong equation. And it happens so often that it really messes up your work. You end up getting no marks at all for the question, and it's really upsetting, and your marker feels really bad for you. So taking a moment to just think about what each of these equations are really will help just get your head in the right space before your exam. Okay, when it comes to trig, we'll do something similar. So these are our equations. Now let's read our question. Sketched below are the graphs f of x, which is equal to ax squared plus q. Okay, so that is my parabola. So that's this guy over here. And I love highlighting in exams, but it's up to you if you're a highlighter or not. You don't have to be. And then we've got gx, which is equal to x plus 3, which is that guy over there. Okay. The y-intercept of f is e, and that is 0 and 18. So that's this point over here. And the y-intercept of g is at b. Both graphs have an x-intercept at D. The second x-intercept of F is the point H. Okay, so in the very first question, they are asking us to determine the coordinates for D. Those coordinates over there. I know that that is the x-intercept of our straight line and it's the x-intercept of our parabola, but I don't have enough information at the moment to use my parabola to find the x-intercept. So I'm going to use my straight line. Now, if it's the x-intercept, what would my value for y equal? Beautiful. Okay, we're looking for an x-intercept, which means that y is going to be 0. Okay, so I'm going to say 0 is equal to x plus 3. I'm just going to move the 3 over, which means x is -3. But now we need to be really careful, and this is like a place where people often lose marks, such a silly place to lose marks, but they have said in this question the coordinates of D. And so if we don't actually give the coordinates of D, we're not going to get both marks. And the coordinates of D are x is -3 and y is 0. So you'll get 1 mark for showing working and 1 mark for your answer over there. So for those of you who've done it, that's how you're going to mark that question. Okay, question 1.2, determine the values of A and Q. So A is over there and Q is over there. One of those is really easy to find immediately. Which one is that? What value do I know immediately? Good, Portia. And what is Q going to be equal to? Yes, nice. Okay. Yes, Tiamo. Okay. So we know that Q is 18 because it is our y-intercept of our parabola. So we know at the moment that we've got y is equal to ax squared plus 18. Now, when we get to this point, when we're trying to find A, we know from our classes that at this point we need to sub in another point. We need to sub in a set of coordinates. We don't have any coordinates. What do we sub in? What can we sub in when we don't have anything? What are we going to do? Ah, yes, 1.1's answers. Remember, your maths teachers have put your questions in a specific order for a reason. They have scaffolded it, which means that one leads into the next, which leads into the next. So we know that the coordinates for D are -3 and 0, which means we can sub those in. So we're going to sub in -3 and 0. And remember, that's x and that's y. So we're going to make y equal to 0 and x is going to be -3. I'm going to move my 18 over and I get 9a. I'm going to divide both sides by 9 and I see that a is equal to -2. Okay, so a is equal to -2 and they've just asked us again, look at your question, make sure you're giving them what they've asked for, the values of a and q. So let's just make sure that we give it to them exactly like that. A is -2 and q is 18. If they asked for the equation of the parabola, then that's what we would give them, but we have to give them exactly what they asked for. Okay. Next one, I will be very excited to get some correct answers considering how much time we have spent on these types of questions. What is the range of f? So what is the range of my parabola? Who can tell me the range of my parabola? Is no one wanting to speak today? I have had no hands up. It's so unusual for you guys. Normally I have so many voices that I hear. Who can tell me what my range for y? Oh, I've given you a sneaky answer there by mistake. Who can tell me what my range of f is? What is my range of my parabola? Think about what range means. Think about what this means. Don't be shy, guys. Remember, I don't mind if your answers are wrong. Tell me what you think the answer would be here. It doesn't matter if it's right or wrong. I'm happy either way. What do you think our answer is going to be? What would be the range? Okay, so we've got -∞ 18. I like it. It depends on how we've written that, but we need to be careful. Okay, so another option is YER, so Y is anything. Keep the answers coming. Say what you think it would be. Okay, so Unati's thinking because we've been working in the hyperbola, she's got the mind in asymptote zone. Okay.
Also, look at that thing that I sent.
So some of the answers that are coming through, I can see that you're on the right track with certain things, which is awesome. Okay, just a little heads up and a note. You're not going to get like a y is not equal to something or an x is not equal to something unless there's an asymptote involved. Okay, so those ones are only going to be when we have an asymptote. And generally, in grade 10 at least, this is only going to be when you're dealing with a hyperbola. Okay. When we're dealing with a parabola, basically what we want to do when we're looking for range, because range are possible y values. Nice, Kelly. We're saying, what are any of my possible y values? Okay, and so basically we're looking at that yellow part that I've highlighted. What are any possible y values I could have? This arrow over here and this arrow over here is telling me that I'm going all the way down to negative infinity. Okay, that's what that's telling me. Ooh, my infinity signs are not great. Okay, what is my maximum value of my parabola? What's my maximum value? What's my maximum value? 18, exactly. My maximum value is 18. That's telling me that y, the maximum y value for my parabola, maximum y value is equal to 18. There's nothing higher than that. Do you see my graph doesn't exist when it's higher than that? When y is 19 or when y is 20, then that's not on my parabola. Okay, so basically what this is telling me is that my parabola exists when y is less than or equal to 18. And we can write it like that, or we can write it as negative infinity as my smallest number and positive 18 with a square bracket as my maximum number. So you can write it either the one way or the other. So when we're dealing with a parabola and we're looking at range, we're thinking what is our maximum or what is our minimum, depending on the type of shape it is. Okay, cool. 1.4, determine the length of EB. Now to determine the length of EB, you're going to want to see what your straight line equation is. Let's have a look at it. It's our green one up at the top that we highlighted. Our straight line equation is y is equal to x plus 3. So what does that mean about my coordinates for B? What are my coordinates for B? Don't overthink it. Have a look at your equation. If our straight line is y equals x plus 3, what are our coordinates for B? Kutlana, well done. Yes, guys. X is 0 and y is 3. Because remember, that value over there, that C value, that's telling us that's the y-intercept. It's telling us where it crosses. Okay, so it would be 0 and 3. So now that we know that, this question is actually not so tough. This question is saying, what is the length of EB? What is this length over here? What's that purple length that I've highlighted? Look at your information and then see if you can tell me what my length of EB is. Yes, Portia, lovely. Yes, guys. Great. Okay. My length of EB would be E, which is 18, minus 3. So the length of EB is 15. Not so bad, hey? You just have to think about things sort of slowly. And then the last question of this particular question is determine the coordinates of P. Now, this is something we've spoken about in previous lessons. What is P? What is it? It's something special. What is P? Have a look at where it is. Have a look at where it's situated. And then tell me if you can. So it's not our turning point. Our turning point will be E. This will be our turning point up at the top. Great, Canva. It's an intercept between the lines. Okay, it is a point of intersection or interception. It's where they intersect. Okay. Okay, so basically, that point over there is where both graphs are equal to each other. So at point P, my straight line is equal to my parabola. Okay, they are the same as each other. I'm just going to write that over here. It's when my straight line is equal to my parabola. Okay, so let's have a look at what those equations are. My straight line equation is x plus 3. Okay, my parabola equation, we found A and we found Q. So that's going to be negative 2x squared plus 18. we're looking at that point. So we are looking at where is x plus 3 equal to negative 2x squared plus 18. Now, when we get to this point, we just solve it like a normal equation. So we say, cool, I need to move that onto the other side and my 18 onto the other side. So I'm going to have 2x squared plus x plus 3 minus 18 is equal to 0. So 2x squared plus x minus 15 is equal to 0. Now I need to do a trinomial to solve for my values of x. Okay, I've got 2x and I've got x. Now I have to break up this 15 so that I get an answer of 1. So let's try and play around and see what we would end up getting. If I put my 5 here and my 3 here, I would have 2x times 3, which is going to give me 6x, and x times 5, which is going to give me 5x. And if I've got 6x and 5x, I definitely can get 1x if I say 6x minus 5x. So that just needs to be a minus over there. And just like that, we have solved our trinomial. Remember that that's one bracket and that's one bracket. So we're going to say 2x minus 5 is equal to 0. Oh, sorry, let me not do that just yet. 2x minus 5 and x plus 3 is equal to 0, which means x is equal to 5 over 2, or x is equal to negative 3. And those would be our two values for x. Now we have to look at our graph. So we're going to go back up there. Okay. Which one of those x values is the x value we care about at that point of intersection? Which one of those x values? Because at the moment we've got 2. We've got where x is 5 over 2, and we've got where x is negative 3. So that's saying that my straight line and my parabola are equal to each other when x is 5 over 2 and when x is negative 3. So which one of those x's? Yes, great. And if we look at our graph, we can actually kind of confirm that what we did was right, because over here, that's also the point where our parabola and our straight line are equal to each other, and that is when x is negative 3. So we already know that because we solved it earlier. Okay, so at this point of intersection, it's going to be when x is 5 over 2. And then we can just sub it into either equation, and it's normally easier to sub it into your straight line formula. So we're looking for y when x is 5 over 2. And then you can literally just add that straight onto your calculator exactly like that. And you should get 11 over 2. And so my coordinates of P are 5 over 2 and 11 over 2. Okay, what I would love is some kind of rating, either if you did the questions, how they went, and if you didn't do the questions and you're sort of going through this, yeah, these lessons are being recorded, and if you're going through this with me in the lesson, that's also fine. I'd like to get an idea of how you found just this first question, so just question 1. You can give it to me as a scale of 0 to 10. If it's just 1.4, that's not bad. But a scale of 1 to 10, how you found question 1. Let me know how it went. Yeah, 1.5 is a tricky question. Unfortunately, it is one that you are likely to see. Just remember, as soon as you have a point of intersection, just make your graphs equal to each other. And even just having that one line of having them equal to each other, you at least get a mark, because you're showing the marker that you know that the graphs are equal at that point. So you can also do it that way. Felt confident? Okay. Oh no. Well, hopefully it was helpful and you were able to learn something from it. 1.5 is tricky, guys. If you found 1.5 hard, that's totally fine. And 1.4 looked like it was hard, but it wasn't actually a bad question. Hopefully 1.5 feels a little bit easier now that we've gone through it together. Okay, let's try our next one. Great. Okay, so in our next question, this is question 2, we have been given an equation, h of x is equal to -4 over x minus 2. My very first question to you is, what type of graph is this? -4 over x minus 2, what type of graph is this? Yes, it's a hyperbola. Great. Okay, so we know it's a hyperbola. Let's think about some other things that we know. What does this number over here tell us? So what does that -2 tell us? So not our y-intercept, but our y-asymptote. So that is our y-asymptote. Oh, I'm missing a p somewhere. There we go. Okay. And then we've also got this number up here. So that's our a value, and our a value is negative. Great. And our horizontal asymptote, great way to say it. Also, Portia, if you're thinking graph moved down by 2, that's also great. If a is -4, what does that mean about our hyperbola? So a is equal to -4. What does that mean about our hyperbola if a is negative? Quadrants 2 and 4, excellent. Okay, so before we even jump into the question, if we sort of just look at what we've been given and we get an idea of what we're dealing with, so we're literally spending like 10 seconds on this, we know our asymptote's going to be at -2, and then we're going to be in this quadrant and this quadrant, and we get a vague idea of what we're dealing with. It really helps us as we move through the question. Okay, because it also, we can use it as a way to check if we're doing things correctly. So 2.1, write down the equations. That's the key letter in the sentence. Write down the equations of the asymptotes of h. 2 marks. Tell me what they are. Yes, good. X is equal to 0 and y is equal to -2. 1, 2. These questions have been given to you to help you draw your graph. 2.2, determine the coordinates of the x-intercept of h. If we are looking for the x-intercept, what do we make what? If we are looking for the x-intercept, what do we make what? Yes, the x-intercept, we make y equal to 0. Okay, so we say 0 is equal to -4 over x minus 2, and now we solve for x. So I'm going to bring that 2 over. 2 is equal to -4 over x. I'm going to multiply the 2 by x, so 2x is equal to -4. And then I'm going to divide both sides by 2, and I see that x is equal to -2. But remember, read the question, the coordinates. They want the coordinates, which means we need to say our coordinates of the x-intercept, which would be -2 and 0. We always have to give them the answer the way that they have asked. This one, you'd get 1 for working, 1 for your answer. Okay. Draw a neat sketch of the graph of h. Clearly indicate all the intercepts with the axes and the asymptotes. Please, can you all sketch this or show me if you've tried it? Then show me a picture of what you've tried, but I'd love to see how these graphs are going. So if you don't mind, like obviously if you're stressed about like not showing me your face in the video, that's fine. You don't have to show me your face, but I'd love it if you could hold your graph up to your camera once you've quickly sketched this and give me an idea so I can just tell you if there are things that you should work on, what looks good, what needs a little bit of help. So you can kind of get a little bit of some personal attention. So once you've got the graph, So quickly sketch this graph for me. Oh no, I'm so sad you're confused. Hopefully, like, you can see now that it's not so bad. Once you've sketched your graph, and remember, I don't care if it's perfect or if it's completely wrong. I just want to get an idea of where you're at. Then just quickly show me your picture. So like, take whatever your picture looks like and just show me in the camera like that so I can see. So you don't need to be embarrassed. You don't need to show me your face or your background. I just want to see the picture of your graph. So get them drawn, sketch it out, and then show me a nice little picture. Portia, can you go a little bit closer for me? That looks great. I love the arrows. I love the asymptotes. I love the labels, 100%. Excellent. Thank you. So exactly what Portia did, if you could do something like that. So basically just like show me a picture of what your graph looks like in your camera. And if it's terribly wrong, that's also fine. At least then I will be able to tell you where it's going right or wrong. So sketch this out if you haven't done it already. And then just show me a quick picture of what it looks like. Tianwa, can you go a little bit closer for me? Oh, you even put in your lines of symmetry. I love it. That's great. That looks awesome. Okay, so you see your top, the line that you've got going on that top left quadrant, in quadrant 2, I would maybe extend its arm up a little bit because it's got quite a short little arrow at the top of it. So I might maybe make that line a little bit longer, but otherwise it's great. Kaylee, let me have a look. That's looking good, Kaylee. That's looking great. Just, yeah, I can see your x equals 0. Your one, so your arm that's happening in quadrant 4, he looks a little bit like an L. Try and make it a little bit more curved, but it looks great. No, no, me, so, oh, great, thank you. Perfect. That's great. That's excellent. I love it. Sorry, no, no, me, so I was talking to you if that wasn't clear. That was great. Buchle. Yes, I'm liking that as well. Great. Thank you. Okay. If anyone else has one just now that they're wanting to show me, just let me know, because I can't be on my teaching screen and on your videos at the same time. So if you have one that you're wanting to show me, just let me know. Okay. All right. Let's just jump into this though. So when I neatly sketch this, first thing I'm going to do. Okay, you can press hard with your pencils. I won't judge. Is we're going to make our axes, okay, and we are going to draw in what we have. So the first thing that we know is we know that we have that asymptote, which was at -2. So we're going to draw that in. Remember, you're going to use your rulers and you're going to use a pencil. So you're going to make sure that this is nice and neat. I'm going to say that is when y is equal to -2. Our other asymptote is when x is equal to 0. So don't forget those. Okay. Then I'm actually going to draw in my arms. Nice curved, nice long arms. Make sure that they have arrows on their ends. And then we've actually already calculated that point over there. We calculated that point to be -2 and 0. Okay. So what we have done is let's just double check our question and make sure we've answered everything. We've drawn a neat sketch of the graph. Done. We have indicated the intercepts with the axes. Okay. Yes, we did that over there. And we have shown the asymptotes. So that one asymptote was where x is 0. The other asymptote is when y is -2. Okay. Then I'm just going to talk you through this. This is not in our question, so you wouldn't have had to do this. But if they asked you for your axes of symmetry, then you would have a line that goes like that, which would be y is equal to +x - 2. And if they wanted the other one, it would look like that, which would be y is equal to negative x minus 2. But they didn't ask for it, so you don't need to have that rainbow color. Okay. To the learner who's just messaged, if you haven't done this topic yet, please don't panic. First of all the videos that we have done with functions are on the website, so you can go and watch them. And if you haven't done this topic, it probably won't be in your exam yet. So don't stress too much. Okay. Okay, let's have a look at the next question. Write down the domain of H. Domain. What does domain want from us? What is domain asking? If range was asking for the possible y values, what is domain asking us? What is domain asking us? Yes, the possible x values. Okay. Okay, so now before we even jump into this, what is x not allowed to be in a hyperbola? What is x not allowed to be? Yes, x is not allowed to be equal to 0 because it's an asymptote, okay? When x is equal to 0, it's an asymptote, and the asymptote is our friend zone, okay? We are never going to cross over that friend zone. It is solid, okay? And so the asymptote is what x can never be, which means we know that x is not allowed to equal to 0. Okay. Now let's have a look at our arrows. This arrow is telling us that we're going to go all the way into negative infinity. And this arrow is telling me that we're going to go all the way to positive infinity. So what would be my domain for this hyperbola? I know that I've got x cannot be equal to 0. Great. So I could say x can be any real number, but x is not allowed to be equal to 0. Or you can say that x is between negative infinity and positive infinity, but x is not allowed to equal 0. Okay, either one of those is fine. This is generally sort of thought of to be the easier one, but you must do whichever one you feel more comfortable in. Okay, so the next one is one that we actually briefly spoke about now. Determine the axis of symmetry that intersects with the graph, which means that it actually touches our graph. It's going to go through our arms. So if I draw in this axis of symmetry, is it touching either of my arms of my hyperbola? Are there any points of intersection with that line that I've just drawn? Does it touch either of the arms in the hyperbola? Yes or no? No. Okay, so that means it doesn't intersect with the graph. So then let's look at our other one. Does that intersect with our hyperbola? Does it touch our hyperbola's arms? Yes, it intersects there and it intersects there. Okay, so that is the equation they are wanting. Now, when we have our equations, remember your gradient is always going to be positive 1 or negative 1. This is a negative gradient, so we know we're going to have negative 1x, and then we use our asymptote for our plus c, which is negative 2. So the axis of symmetry that intersects with the graph is y is equal to negative x minus 2. Okay, that brings us to the end of question 2. Same idea. I'd like to get an idea with a scale option over here, scale from 0 to 10, how this question went. If you had done it prior to today, that's great. If you did it now while I was talking you through, tell me how this type of question went. Hopefully this feels like it was a little bit easier because we've just been doing hyperbolas in class. Cool. Nice tries. Loved it. Oh, I love that. Great. Okay, one more functions question, then we're going to jump into trig. Oh, you wrote down both. Okay, so just be careful, because if you wrote down both, depending on what you wrote down first, will be the answer that you're given. So let's just take that as a quick example. Let's say we didn't read 2.5 properly. Okay, and let's say we wrote down both axes of symmetry. So we wrote y is equal to positive 1x minus 2, and y is equal to negative 1x minus 2, because we wrote down both, okay? So let's just say that that happens. Now, when your teacher is marking this, they have to follow the rules that we follow when we mark matric exams, and they are only allowed to mark your first answer. So those of you who think you're being sneaky by giving more than one answer in a test or an exam situation, your teacher's not even vaguely allowed to look at that. So even though that's the right answer, she's not allowed to give you a mark for that. She has to mark the first thing you answered, and the first thing you answered for this question is wrong. So just be careful that when you're reading this, you read the question really, really carefully, and you only provide the answer that they're actually asking for. Okay. Oh, but that was just luck. Don't fall for that trap later. Oh, you got your quadrants wrong. It's okay. It happens to the best of us. Just keep on trying. It'll get better with the more practice you do. Okay, so question 3, we're looking at another parabola. The graph of f, which is ax squared plus q, we've got b and c, they are the x-intercepts of f, and the point -3 and 5 lies on the curve. Determine the equation of f. Who thinks they can tell me how to start this, what I can definitely know, and then what I'm going to put into my equation? Who can give me some kind of an idea of where to start with this if we're trying to solve this equation, which means I'm trying to find a and I'm trying to find q. Beautiful. We know q is -4. Okay. So y is equal to ax squared minus 4. So basically, we want to put in q. What's the next thing we want to do if we're now trying to find a? Good. We're going to substitute. We are going to substitute -3 and 5. Excellent. So we're going to sub in -3 and 5. So 5 is y. X is -3 minus 4. I'm going to move that 4 over. So I'm going to have 9 is equal to -3 squared, which is 9a. So all I did there was I moved my -4 and it became +4. So 5 plus 4 became 9. And then I'm going to divide both sides by 9. And I see that a is equal to 1. Okay, now we've got to be careful. Let's see what the question said. Determine the equation. The equation would be y is equal to 1x squared minus 4. That is what they are asking for. They are asking for the full equation, and we have to give them what they ask for. Okay, not so bad. And that's 4 marks. It's a lot of marks for a question like this. Cool. 3.2. Write down the coordinates of C. So let's have a look at what C is. Can anyone give me some guidance about what C is and how I could begin to start looking for my values for C? What is C? Don't be scared, guys. What is C? Have a look at where C is. What is C? Yeah, Portia, that's definitely true. Y would be equal to 0 at C because C is, yes, Ria, C is an x-intercept, okay? It's an x-intercept. It is where it crosses my x-axis. And at my x-intercept, y is equal to 0. Okay, so all we have to do to find our coordinates of C is make y equal to 0. So we're going to say 0 is equal to x squared minus 4. Now remember, you can do this the way where you take the 4 over and you can square root both sides, or you can do it with factorization. So we can say 0 is equal to x plus 2, x minus 2, which means x is equal to plus or minus 2. Or you could have said, you can move your 4 over And then we just need to be careful when we square root it, we have to have that plus and minus. Okay, so then it would be plus or minus 2. Now we need to look at where C is. Okay, so looking at where C is on our graph, what would be, because remember, we're trying to find the answer to exactly what they're asking for here. What would be my coordinates for C? Yes, there we go, guys. Okay, so we can see that C has a negative x value, which means the coordinates for C will be -2 and 0. Again, we're making sure we give them what they ask for. 2 marks in the bag. Okay, this one I will be very excited for you to get right after our conversation in question 1. What is our range of this parabola? So that's my parabola. What is my range? What are my possible y values for this parabola? What are my possible y values for this parabola? Have a think and then write down what you think your answer will be. It doesn't matter if it's right or wrong. Just tell me what you think your answer will be. Okay, so Portia's saying y can be any real number. Do we agree with that? Do we disagree with it? What do you think it would be? So write down what you think your answer is going to be here. Tiawa, is there an asymptote in this parabola? No, so if there's no asymptote, then we definitely don't have the y cannot be equal to something. Okay, so I'm seeing some good answers. Sometimes they're written in the wrong way, so we just need to be careful. But I'll talk to you about that now. Okay, so first of all, the first answer that came in was that y can be any real number. All right. So my first question to you, by saying that, you're saying y can be anything. Can y be -5? If y is -5, is my parabola part of that? Does it exist? Does my parabola exist when y is equal to -5? If -5 is done here? No. Okay, so if it doesn't exist for all numbers, then that can't be the case. Okay, so that's never going to be the case for a parabola. So then we have to say, well, what is this value? This value over here is my minimum value. That's the smallest that my graph can be. And that is when y is equal to -4. That is the smallest value for where my parabola can exist. Okay, so basically y needs to be greater or equal to -4. Or we would say that it can be from -4 to positive infinity. Now, the reason that I just want to talk about the second option over here is because quite a few of you gave me an answer that was close to that, but it was a little bit different, and you wrote positive infinity and then -4. We're actually not allowed to write it like that when we're working with interval notation. This always has to be the smallest that it can be, and this is the biggest it can be. So we need to write what's my smallest that it can be and what's the biggest it can be. So either we can write it as y is greater or equal to -4, because it is allowed to equal -4, or we would say that it's between -4 and infinity. So well done to those of you who got that one right. Okay, this question was a tough question. I'm just going to warn you. So it's an extension question. It's like a problem-solving question, but I thought let's just put it in to see how people feel about it. Let's try and break out what this question is actually asking. If you struggled with it, please don't panic. It's very normal to have struggled with this question. They're saying, what is the range of H? H is a hypothetical graph. It doesn't exist at the moment, okay? But they're telling that H is where F, which is what we've been dealing with, is now negative, which means it has been reflected over the x-axis. So that negative sign is telling me that it's been reflected over the x-axis. Okay. And this is telling me that it's been moved down 2 units. So at the moment, the parabola that we've been dealing with, the parabola of f, let me draw it in black. The parabola of f looks like this. Okay, this is f. This is the one that we have been dealing with, and that's -4. Okay, so now let's break it up step by step. First step, if it was reflected over the x-axis, so now imagine it's being reflected like a butterfly. If this is -4, now it's going to be +4, and it's going to be reflected over the x-axis. So it's going to literally be like a reflection of it. You're going to imagine that you're folding over the line of your x-axis. So that's step 1. That's step 1. Now, step 2, they're telling us that we are moving it down 2 units. So instead of this maximum point being 4, our maximum point is now going to be 2 because I'm moving down by 2 units. And this orange graph that I've just drawn is our graph H. And so now with that orange graph, they're asking us for the range of the orange graph. It's when y is less than or equal to 2 or -infinity to 2. But this was a really tough question. It was really just in there for anyone who wanted to extend themselves or think about something in a bit of a different way. It's only out of 1 mark, so that it's been given like that so that lots of people wouldn't just lose the mark, like wouldn't lose lots of marks. It's really just to try and stretch for anyone who wanted to give it a go. Did anyone manage to try this one or have a look at it, or did it just scare everyone away? I'm very curious to hear. Did it just scare people? It is a scary question, so I would understand that. Oh, you like it, Mpumi. That's great. Awesome. That makes my heart happy. Cool. It's okay. It's okay if you skipped it. I understand that. Sometimes when you're like in a situation, in a test situation, and you see a question like this and you think you're going to spend a lot of time on it and it's only worth 1 mark, then it's not worth you spending that kind of time on. So skipping it sometimes is the right thing to do. You got none on this page, right? Oh no. Okay, so same thing we did for question 1 and question 2. Give me an idea. How did this question go? Give me a question rate from 0 to 10 on how this parabola question went. 0 to 10. Siamo! I think maybe just go through this, video quite carefully afterwards. And remember, you have the memo, so also like look at the memo really carefully. The last question was tough, though. The last question was there to stretch you. Okay, let's move into our trig zone. Now, some of these trig questions are going to be really nice and easy, which we're going to be able to zoom through. And then some of them we'll want to spend a bit of time on because we've only got 35 minutes left. Okay. So these ones, I'm hoping that we have lots of people who are able to give me nice answers over here. When we get into our trig questions, the first thing that we want to write on our test paper is our SOH CAH TOA. So we want to write sine, we want to write cos, and we want to write tan. No, don't be petrified and depressed. Remember, that's why we have these classes, so that you can see where you're going right and where you're going wrong. And you can go through this video again. You can have a look at it nice and carefully. You can spend some time on it and ask questions if you need to. That's why I'm here. In the Bentley, how can I help?
Oh, I wanted to know if I could give the answer.
Oh, yeah, please do. Let's zoom through. Well, hold on. Let me just first label this guy. So if that's my theta, then this is going to be opposite. This is going to be my hypotenuse, and that will be my adjacent. So this trig, this will be in paper 2. Okay, in the Bentley, talk me through 4.1.1. What is cos theta going to be?
Well, ma'am, since cos is adjacent over hypotenuse, and we already have AC, which is the hypotenuse, then it would be AB over AC.
Beautiful. AB over AC. I'm just going to keep you on this call while we're going. 4.1.2, tan theta is going to be what?
Since tan is opposite over adjacent, then I'm assuming that it would be CB over AB.
Well, let me just write these over here so everyone can see. Okay, so tan is opposite over adjacent. Beautiful. CB over AB. Love it. Okay. 4.1.3, sine 90 minus theta. Who thinks that they can tell me this one? This is a sneaky one. This is one that we spoke about in trig when we had our lessons, but it is one that often comes up in your tests and exams. So it's one that I want you to think about. And remember, I told you not to panic when you see a question like this. Okay, so I've got my first answer coming in. Let's have a look. If I'm looking for 90 minus theta, first I have to think about which angle that is. Okay, this is 90, this is theta, and this angle here will be 90 minus theta. So if I write that in, then that helps me a little bit. Okay, if I'm dealing with that as my angle, then this is my opposite, and this is my adjacent, and this is still my hypotenuse. Okay, so if I'm saying what is sine of 90 minus theta, that's going to be my opposite, which is AB, over my hypotenuse, which is AC. Anyone out of getting that right? I think Katlano got that right. Oh, but then you changed it to CB. Yeah. Okay. So if we're looking for when we have this 90 minus theta, no, don't doubt yourself. When we have this 90 minus theta, it's always going to be the other angle you have left in your triangle. It's going to be whichever one is left there. Okay. Then the last one is saying, well, if we have CB over AC, so we have CB over AC, what would that be? And so if we have a look at our picture, we say, well, that's our opposite over our hypotenuse. Okay, opposite over hypotenuse, which means it's going to be sine. So sine theta is going to be equal to CB over AC. So if you're marking these at home, if you gave these a try, it's 1 mark for each of them. These are your 4 marks. Easy peasy lemon squeezy. You're sort of guaranteed a nice easy question to ease you into trig, which will be good and helpful. Let's move down. Okay. Determine the value of theta in the diagram below. So we are trying to find this value over here. I'm going to the first thing I'm going to do is I'm going to label my triangle. So that's going to be my opposite, that's going to be my adjacent, and that's going to be my hypotenuse. Okay. Oh, well, you could have used 4.1.3. So if you used 4.1.3, if you wrote cos 90 minus theta, that's also equal to CB over AC. So if you wrote that as your answer, that's also right. If you used the idea of 4.1.3. Okay, so the first thing we did is we labeled our triangle, and now we're trying to find theta. So we need to see, well, what do we have? Okay, and we have O and we have A. So we are going to use tan because tan is O over A. So I've got tan theta is equal to 4 over 6. Where do I go to from there? What am I looking for? And so what do I need to use? Shift. Yes. As soon as we are looking for theta, we are looking for an angle. As soon as we see theta, we are looking for an angle. And when we are looking for an angle, we have to think with our calculators, we are going to use shift. Okay, that is what our brain needs to think. If we're looking for theta, We're looking for an angle, which means we need to use shift. So we're literally going to type into our calculator, and I want everyone to type this so that I can see if anyone has an issue. If you're on the wrong setting on your calculator, we can get to the bottom of it now. We're going to say shift, tan, and then you'll see it comes up. What it looks like at the moment is you'll have tan to the -1, and then you'll have brackets. We're going to push the fraction key, and we're going to put in 4/6, and then you're going to push equals. So shift, tan, fraction, 4/6, close up that fraction, equals, and we will see therefore theta is equal to, oh, you know what I'm going to say, guys. Thank you, Ria. 33,69 degrees. You need to give me your unit here. Okay. The other thing is quite a few of you answered 33,7, unless it says to 1 decimal place. I need 2 decimal places. Unless it is stated otherwise, you're going to give me 2 decimal places. Okay. Good. Awesome. Okay. Before I move on to the next page, I know it's the same sort of idea. Just give me an idea about how this page went. 0 to 10. How are we feeling with trig? Nice. Okay, so trig is definitely like our happy place. Infinity out of 10. Great. In the Bentley, where's that 0.5 coming from? Is that 0.5 coming from 4.1.3? Okay. 4.3, determine the length. Okay, now let's just be careful. We are looking for the length of x, and if we are looking for the length, we are not using shift because we are not looking for an angle. We are looking for a length. Okay, so let's assess our situation. We're first going to label our triangle: opposite, adjacent, hypotenuse. What trig ratio am I going to use if I'm trying to find x? Cos. Excellent. Cos is equal to adjacent over hypotenuse, which means cos of 42 degrees is equal to adjacent, which is 3, over my hypotenuse, which is x. Now, if you've solved this at home already, that's great. If you haven't solved this, please, can you all solve it now? I would like to know what my value for x is. So quickly have a look at it and tell me what my value for x is. And I want it to 2 decimal places. 2 decimal places. Nice, Portia. Oh, careful, oh, Portia. Portia. There's something wrong there. Think very carefully about what's wrong. Try and tell me what's wrong.
Bentley has a hand.
And immediately you're giving me my answer.
Yes, ma'am.
What's my answer?
4.04 centimeters.
Thank you. Centimeters. Definitely not degrees, guys. We are not dealing with an angle here. We are dealing with a length. Okay. So x, I'm just going to show you how we would do this for those of you who struggled. We're going to multiply that x onto the left-hand side. That's equal to 3. And then we're trying to isolate x. We want x to be alone. So we're going to say, therefore, x is equal to 3 over cos of 42 degrees, which means x is equal to 4,04 centimeters, not degrees. It is a length. Okay. 3 marks. 1 mark for getting your setup correctly and choosing the correct trig ratio. 1 mark for setting like you're moving, so setting it with your equation, and then 1 mark for your answer. Now, the sad thing, Portia, is if you had written 4,04 degrees, you would not get that final mark because you're indicating that you don't know that it's a length and you think it's an angle. It's a very sad situation, but true. Okay, Let's move on to our next one. ABC is an isosceles triangle with AB equal to AC. Okay, so that's just telling us, this is just telling us that it's an isosceles triangle, that length is equal to that length. Okay, that's all that's saying. That sentence is telling us. Gosh, I can't draw straight today. Okay, they're also telling us that AD is perpendicular to BC. So that means that if this is 90 degrees, this is also 90 degrees over here. AB is equal to 9 centimeters and AD is equal to 6 centimeters. Determine the following. So, William, if you wrote it without centimeters, it depends on how strict the teacher marking your exam is going to be. So, often there'll be like a maximum number of marks that you can lose for not using units, because if you haven't used units in your whole exam, you're not going to get penalized every single time. That's not fair to you. So maybe the maximum for your school is 5 marks, or maybe it's 2 marks. It depends on what your school's policy are. So then if you have not used units like for 2 questions prior, then they would have taken those marks off, if that makes sense. So you may lose the mark, but you may not lose the mark, depending on if you lost marks earlier. I feel like I gave you a very convoluted answer there, but hopefully you understood what I was talking about. Okay. All right. In the Berkeley, talk me through. What am I going to do?
So, ma'am, since we're trying to calculate an angle, we have the opposite and we have the hypotenuse, so that means that we use sine.
Good.
So, and in situations where we're trying to find an angle, we use sine inverse. So
Good.
I went sine inverse 6/9, which gave me 41.8 degrees.
Okay, so I really like that. First, set up what your equation would look like. So first, set up that sine of B is 6/9. Just like have that line.
Yes, ma'am.
Because you will get a mark for that. Basically, you get a mark for indicating that you know that you're using sine.
Yes, ma'am.
Okay, cool. Okay, so sorry, talk me through. Where did you go to from there?
And then since we were looking for an angle, I did sine inverse or sine shift.
Good.
Or shift sine. 6/9, which gave me 41.81 degrees.
Beautiful. Excellent. Perfect. Nice. Okay. So what we've done over here is we looked at what information we had. So we had the opposite and we had the hypotenuse. We used sine. And if you write this line over here, you're going to get a mark, because that's saying I know that I need to use sine and I know that I'm using my opposite and my hypotenuse. So we get a mark for that. And then we get a mark for knowing that we're using our calculator and that we're using shift. And then we get 41.81 degrees. Okay, now with these types of questions, I really recommend, as you figure it out, to put it into your picture. So this over here, oh goodness, this over here is going to be 41.81 degrees. Just chuck it in there, because then you know that it's there. Okay, next thing that we are looking for, just going to get rid of these highlights so that we can write things. The next thing that we're looking for is BC. We are looking for that whole line over there. I'm very curious if anyone has a suggestion of what we could do. Okay, so we know that this is 9 centimeters. There are different things that you could do. You don't have to use trig for this question, but I'm very curious to think of what we could do. Okay, so Tiamo is saying Pythagoras. Pythagoras is a great option here. Okay, we can definitely use Pythagoras. We can use Pythagoras because we have this side and we have that side, which means we can find that side over there. Okay. Yes, Kutlano, excellent. Congruency is another great idea, because we can see that they have got 2 sides that are the same, the 9 centimeter and the 6 centimeter, and the angles are the same because it is an isosceles triangle, which means that BD is going to be the same as DC. They're going to be equal to each other. So we can use all of those ideas. Okay, we could also use trig. We can choose exactly which one we want to do. So in the Berkeley, which one did you decide to use?
Ma'am, so what I did was I used Pythag to get BD.
Okay, so
And
we
then,
said 9 squared minus 6 squared is equal to BD, correct?
Yes, ma'am. And then since AD is common, which is 6 centimeters, and AC is the same as AB. So I 2 of the sides, I use Pythag again, or I just doubled it. So BD
Okay, yeah,
times
so you
2.
could definitely use Pythag again, but you can also just double it. So that's great. That's a great idea. I'll show you how you could do it with both. The Pythagoras way is probably the easier one for this type of question. So now if we check this into our calculator, we're going to get that BD is going to be 3 root 5. And it's probably best to keep it as 3 root 5 until we have got to our final answer. Okay. So through all of these things that you guys have been talking about, congruency with BD and DC, we know that this is the same as this. Okay. And we know that BD is 3 root 5, which means this will be 3 root 5. So that means that BC is going to be 2 times 3 root 5. We just chuck that into our calculator. And now we can push equals and we get 13,42 centimeters. And that would be the whole length of BC. Okay. So that's one way we can find BC. We could also find BC by using trig. So if I'm trying to find BD over here, if I'm trying to find, yeah, it's sort of correct. I just always would prefer 2 decimal places unless they've told you 1. But I would give you the mark today. If I'm looking for BD and I'm wanting to use trig, I could use a lot of different options because I've got O and I've got H. Okay, so I could say, well, let's use tan, for example. Tan of 41,81 degrees would be equal to my opposite, which is 6, over my adjacent, which is what we're looking for, which is BD. Okay, which means BD is then going to be equal to 6 over tan 41,81 degrees. And that we can just put into our calculator. So 6 divided by tan 41,81. And we'll get the answer of 6,7082 on and on and on. And then if we multiply that by 2, we get the exact same answer up here. So you can do it either way. So then BC would be 2 times that, which will give us 13,42 centimeters. Same. So the light green is looking at doing it with Pythag, the dark green is looking at doing it with trig. That's all. Cool. I'm just going to skip over this question, not because just because of our time, because we've been looking at sides and angles. If we have time, I'll come back to it, I promise. Remember, you will get the memo for all of these. I'd just like us to look at something a little bit different, just in case we run out of time. Okay. Okay, so 5.3, we are looking at trig on the Cartesian plane. Trig on the Cartesian plane. Okay, now this is a section in particular that I think it's really worth taking a moment to write things out so that you know what's going on. Okay, I'd always start by writing our normal trig ratios. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Remember that's SOH CAH TOA. Okay, then I recommend you just draw yourself a little baby triangle. Doesn't have to be perfect. This is just for you at the beginning of your test situation. Okay, this is the angle that we care about. So that would be O, that would be H. Let me make this much bigger because I don't think any of you will see what I'm doing. Okay. That's the angle we care about. That would be O, that would be H, this would be A. Okay. Now let's think about it in terms of X's, Y's, and R's. What would A be? So what would this line be in terms of X, Y, and R? Would it be X? Would it be Y? Would it be R? X. Great. Okay. Next one. What would O be? Yes. And so that means that this guy over here is R. Okay, and so that means that because we've taken time to do this, we can now write our trig ratios using x, y's, and r's. So sine O is y and h is r. So sine will be y over r. Cos will be x over r, and tan will be y over x. Now, if we take time to just write that out, it really helps us as we move forward, so we know we can't make a mistake moving on. Okay, great, Zandasile, I like it. In the diagram below, B is the point -6 and 8. Okay, so Zandasile can already see that R is equal to 10. We're going to talk about Y. Exactly, Claudia, we're going to use Pythagoras. Okay, remember this is your X value and that is your Y value, which means this is 8 and this is our -6. And we are trying to find R, and so we are going to use Pythagoras. Okay, so for those struggling with Pythagoras, I'm just going to write it out in slow steps over here. -6 squared plus 8 squared is equal to R squared. You have to give the reason. It is compulsory. Pythagoras. Okay. So 36 plus 64 is equal to R squared. 100 is equal to R squared, which means R is equal to 10. Done. 2 marks in the bag. Now, once we've got that, I recommend you write out the information you have. Okay, so we know that X is equal to -6. We know that Y is equal to 8, and we know that R is equal to 10. So sort of write this out. And then let's look at our next question. Next question is saying, what is cos theta plus sine theta? So I want you to think about what we wrote up here. See if I can get this all on one page. This might be a bit small. Okay, so think about what we wrote up here. And then think about this. And what I'd love to see is I'd like to see what the first line would look like. So I'd like you to write it in the comments for me so that I can see what your answers would look like. I can see if anyone's making a common mistake that we can deal with. I'd like to know what your first line would look like there. Not necessarily your answer. I don't really care about your answer. I want to know what your first line. So after you see that, what it's going to look like. What are you going to write? The most important thing is this guy over here. And then writing out that next step. In the big chat, I see your hand. The answers are coming through on the chat, so I'm just going to work with answers on the chat for this one. I love hearing your voice. You know that. Great, guys. You guys are smashing this. Awesome. Okay. So cos theta is the same as saying what is x over r, and sine theta is the same as saying what is y over r. And so if we just use what we've just written, that's going to be -6 over 10 plus 8 over 10. Now it's fractions. And remember, the question said without the use of a calculator, which means that all that means is show your working. Okay. So now, because we are adding fractions and they have the same denominator, we're allowed to just add our numerators. So -6 plus 8 just gives us 2 over 10, and then we want to simplify that. And that will give us 1 over 5. And that would be our final answer. Okay, mark-wise here, the -6 over 10, the 8 over 10, and your answer of 1 over 5. 3 out of 3. Okay. Okay, let's see. How did this page go? How did trig on the Cartesian plane go? 0 to 10. And then we're going to dive into some trig equations. Williams is smashing trig. Trig is like, I told you guys when we learned trig, I said you're going to like trig. There we go. Good. Oh, no. All right. Let's jump into some trig equations. I did tell you, I did, and you love it. I knew it. Okay. Okay, so the reason you wouldn't get the answer if you jumped straight from here to 0,2, they wouldn't give you the mark. And the reason they wouldn't give you the mark is because you clearly used your calculator. And they said in the question without the use of a calculator. So if you jumped straight from there to there and said 0,2, they wouldn't. But if you showed all of your working up to this point and then said 0,2, then you would get the mark. Because then you're just using logic of 1/5 is 0,2. So you can use your calculators, guys, in trig. You just have to be sneaky about it. You've got to always just show all of your steps. Okay. 5.4.1 is a nice, easy question. Okay, it's stuff that we've been doing this whole time. So everyone grab your calculators, give me your answer in the chat. Please don't forget your units. I would like to know what alpha is. I would like to know what alpha is. Chuck it into your calculators. We are looking for an angle, which means we are using shift. Yes, guys, nice. Okay, so all we do in our calculators here is we say shift cos 2/5 equals, and we see that therefore alpha is equal to 66,42 degrees. Easy mark. Only one, but it's better than nothing. Okay. 5.4.2. I am trying to isolate this dude over here. What is the first thing I'm going to do? What is the first thing I'm going to do? No. The first thing I'm going to do is not divide. I'm going to add 1. Yes, Ria. Okay. Because remember, think this is one term over here. So we're going to leave that 3 for the moment. We're going to add 1 onto the other side. So we're going to say 3 sine alpha is equal to 1/2 plus 1. I'm just writing out the steps here so that everyone can see, which means 1/2 plus 1, which would be 3/2. Okay, that's our first step, is we want to move the 1. Second step. This is what we're trying to isolate. Now we divide. Okay, so we divide this whole thing by 3. We divide that whole thing by 3. Now, you really, at this point, you can use your calculator, so you don't need to look at that and panic. Literally, you can just push the fraction key and then push the fraction key again. So you'll see you have a fraction over a number, and then you can put 3/2 at the top, and then at the bottom of your fraction, you write 3. So it looks like that in your calculator. And you can just push equals, and you'll see that it's 1/2. You don't need to stress yourself out with trying to figure out how to work that out without the calculator. So we see that sine alpha is equal to 1/2. Oh, my alpha is becoming a bit like a fish. Oh, well. Okay. Now everyone should be fine. Tell me what alpha is equal to. Tell me what alpha is equal to. 30 degrees. Beautiful. Okay, now let's assess how many marks this was out of, so I can show you where the marks would be. Only 2. I might have given you 3 for this, but you definitely will get 1 for the 30 degrees, and then probably 1 for getting to the point of sine alpha is equal to 1/2. Okay, next one. I'm giving you no help at all. I would like to know what alpha is. Yeah, Mr. Strongway, I also would have given 3 marks. I just took these from old papers, but I think they were being a bit schnook with the marks. Okay, guys, I'm trying to find what alpha is in this question. Don't fall for any traps. We'll see. No, don't be scared of it. Take that scaredness away. And then think about what your answer is and give it to me as an answer with 2 decimal places. Just to help those who are looking at this and thinking, I have no idea where to start. Can anyone give me an idea of how to start this question? What's the first thing I'm going to do? Or are we looking at this and just panicking? Exactly, yes. Good. I'm glad you trusted your gut. Okay, the first thing we're going to do, because everything that's next to that tan is in a bracket, it's binding it all together. Okay, so the first thing we're actually going to do is we're going to say shift tan 2 equals. And that's going to tell us what everything in that bracket is equal to. So shift tan 2, close that bracket, is equal to, we're going to see that 3 alpha plus 15 degrees is equal to 63. And we want to give more than 2 decimal places here because we haven't got our final answer. So 4349 degrees. Okay. And now we're trying to solve for that alpha over there. So then I'm going to minus 15. So 3 alpha is equal to, I'm just going to minus 15 from that. And we're going to see that that's equal to 48,4349 degrees. And then we're trying to solve for alpha. So we're going to divide by 3. We're going to divide by 3. And we will see that alpha is equal to 16,14 degrees. And I see a couple of you came with that correct answer in the chat, which is awesome. Nice job, guys. Well done. That was a nice tricky question. 3 marks. Okay, and the last question we are going to go through today, and then our time is run out. I don't know how time works in these classes because it just disappears. We have got, it says, consider tan theta is equal to 2,461. Using your calculator, determine the value of 2 cos theta plus 20. Who thinks that they can tell me how we would start this? How could we start a question like this? Because we're definitely not going to look at this question and think this is too hard for us. There's nothing we can do. Even if we panicked, how could we start? Exactly. The first thing we want to do is we want to figure out what theta is. And we're allowed to use our calculator. Okay, so if I'm trying to figure out what theta is, even if I saw this question in a test or an exam and I thought, I don't know what they're talking about over here, we definitely know how to solve for theta. So always do something. Don't leave blank spaces. Always try something. Okay. So tan theta is equal to 2,461, which means we can find theta. We all know how to find theta. We're going to say shift tan 2,461, close that bracket, and we're going to see that theta is equal to 67,89 degrees. Okay. Where would I go to from there? Now that we have theta, what would I do? Yeah, we have theta. We're just going to substitute it in. That's literally all we're going to do. So now we say 2 cos 67,89 plus 20, close that bracket. And we just chuck that into our calculator exactly like that. Easiest 3 marks in the paper. 2 times cos bracket 67.89 plus 20, close that bracket, equals 0,07. And that's our answer.